Okay, so if you
Yeah.
could, in your books, just put today's date on. I'm not giving you the title just yet, because firstly, this is the end of last lesson, and secondly, the title for today is the answer to a question I'm going to ask you later. So for now, just put the date and put the heading as recap, and then answer these questions in your books.
Finished.
Okay, excellent.
For the last one, do we have to do all three?
No, he says any one, so you just choose whichever one you want, and then just tell me about that one.
Okay, I'm done.
Okay, got 2 more seconds. Okay, pens down, just get your green pens out. If you haven't finished, don't worry, just write the answer down in green pen so that when I see your books eventually, I'll know that you wrote that down after the answers
I
were
haven't
given.
got any pens, I only have pencil.
Oh, okay.
Describe the particle.
Sorry?
Sorry,
Mishka,
I was reading the question. I didn't know I was unmute.
Okay. Right, so Bismillah. So what are the 3 states of matter? Aisha, tell me what they are, please.
Solid, liquid, and gas.
Okay, well done. Fatima A, the next question. The particles of which state of matter have the highest energy levels?
Gas.
Gas. And why do you say that?
Because like they're everywhere.
Okay, and how do you know that they've got a lot of energy though?
Like, is it because like they're separated and like they're moving around a lot?
Something like that, Muhammad?
Liquid.
Okay, and why do you say that?
Because in the particle arrangement, they're not together tightly. They're using the whole space to move around.
That's a good answer, but then if you think about what Fatima just said, she said the gases are spread out even more, aren't they? Because they literally go everywhere. You can't even contain them most of the time unless you've got some pressure.
Gas.
Yeah, it is gas. Okay, Fatima Faisal, you've got your hand up.
Is it because gases move around more quickly?
That's right. So it's not just the fact that they're spread out. It is partly that, but it's also because the particles are moving around really quickly and they're just colliding into every surface they can find. So the word collide just means they bump into each other. So you think of I don't know, if all of you just ran at each other and banged heads, we would say you've collided. So that's what we mean by the word collide. Like, it means bumping into each other. Next question, Mishkat. What happens to the particles as they gain more energy? I think I've just answered that. Just think about what I've just said. Think about what I've just said. If they've got more energy, what are the particles going to be doing?
Moving or vibrating.
Okay,
No,
so they're going to be...
Yeah, they do the same thing as it. For example, a gas, it moves very fast, so all of them move very fast and they're not joined together.
Okay, I mean, the solid would probably still be joined up to a point. Okay, Aisha?
They become more spaced out, and so it changes the matter. And for example, like if the solid was ice, and you put more energy into it, it would become water. And then if you put more energy into that, it would become water vapor.
Okay, so I think all of you, if you put all the answers together, that does answer that question. So what happens to the particles as they gain more energy? Number 1, they're going to vibrate more or they're going to move more, depending on which state of matter it is. Secondly, that will mean the particles are going to move ever so slightly or ever such a lot away from each other. So there's going to be more space between them, you're right. And then obviously Aisha said if that happens to continue and there's even more energy, at some point they actually might change into a different state altogether. So a solid might become a liquid or a liquid might become a gas. And then lastly, we've got the particle arrangement in any one of the 3 states of matter. Mishka, do you want to try that one?
So is it saying like describe one state of matter?
Yeah, so describe the particles in there. So you know when we were drawing the circles yesterday? So just tell me about one of them.
Okay, so the gas, like, which is like, you can call it water vapor or something, it like doesn't stay together like solid. It like goes everywhere and very fast.
Okay, so the particles in a gas go everywhere. They're very fast. How are they arranged, Aisha?
In a gas.
Yes.
They're like they don't have a structure.
Okay, so they don't have a regular shape, so they're just randomly spread apart. Excellent. Moving on from there, I'd like you to try this, see if you can tell me what the name of the change is. So when a solid turns into a liquid, what is it called? When a liquid turns into a gas, what's it called? And what are the rest of them called as well? So just quickly make a note of these. You don't have to write the question, just write the word or the words that describe that change. If you're not sure, don't worry, because I'm going to go through it with you.
Do we have to write like what, like for example, solid to liquid? Do we have to write like what turns from solid to liquid, or do we have to write the actual what it's
No,
called?
just
the
name
change?
what it's called. So what's the change called?
I don't really.
To do.
So if you've got a solid, whatever it might be, and it turns into a liquid, what do we say has happened? That a solid has, don't say it out loud, write it down. So think of chocolate, that's your solid. If you were to heat it up and it turned into a liquid, what do you say has happened to that chocolate? So that would be your answer for the first one. If you finish, if you finished all four of those, then write down the name for when a solid turns into a gas straight away, or a gas turns into a solid straight away. If you don't know that, don't worry, because I don't expect you to know that.
I don't really understand this.
So you're just naming the process. So when, for example, I think it was you, mentioned ice earlier, right? So if ice turned into water, what do you say has happened to the ice? Just the name of that word. That's all.
Miss, I only like so far I've only got one.
Okay. All right. I'll give you a few more seconds and then we'll go through it, okay? And when I go through the words, you might realize you do actually know them. It's just that you've never thought of them in this way. Or maybe you don't know them, whatever. You'll find out.
Yeah, I got two.
Okay. Okay, let's stop there then.
One more time.
Did you say do you want some more time?
Yeah.
I think we'll stop there because I've got quite a bit to get through. If you manage to think of anything while I'm going through it, just jot it down, okay?
Okay.
All right, so the first one, solids to liquids. Aisha, what do you call that?
Melting.
Melting, excellent, well done. Okay, so that's the correct answer. So when a solid, whatever it might be, it doesn't have to be ice, it can be chocolate, it can be wax, whatever it is. If it turns into a liquid, we say it's melted. Mishkat, when a liquid turns into a gas.
Evaporating.
Excellent, well done. Okay, so it's called evaporating. There's another word as well, beginning with a B. Does anybody know it?
Vaporizing.
That's a good one, but I said B. It's a very good one. Okay, yeah, okay, there's another word. Okay, a third word. B. So if you've got some water, for example, and you turned it into water vapor, what did you have to do to it? Excellent, well done. Okay, so we've got evaporation or boiling, or like Muhammad said, vaporization, which is pretty much from here without the E. Okay, the next one, now we're going back, so we're removing the energy. So now when that gas turns back into a liquid, what do we call it? Any ideas? I'll take that as a no. Okay, so imagine you've got a pot of something cooking or boiling, whatever it might be, and you've put a lid on top of it. So that water vapor is a gas, but when you put a cold lid on it, what happens is when you pick that lid up, there's actually water dripping down off that lid. Or if you're in a car or you've got a cold window and you breathe on it, you're breathing out carbon dioxide, but you're also breathing out water vapor. But sometimes it turns back into a liquid and then it trickles down the window. Does anybody know what that's called? No? It starts with a C.
Condensation.
Excellent, well done.
Condensation.
Yeah, condensation, well done. So when a gas turns back into a liquid, we call it condensation. And for that to happen, we have to remove some of the heat. So when a gas becomes cooler, it turns into a liquid. And then lastly, which one?
Condensation.
So that's what this means. Gas, when it turns into a liquid, we call it condensation.
Miss, for liquid to solid, I got solidify.
Okay, excellent, well done. So when a liquid, for example, melted chocolate turns back into chocolate, as in solid chocolate, we would say it's solidified. Does anybody know any other word for when a liquid turns into a solid? Fatima?
I put freezed.
Freezing is also correct, well done. So freezing or solidification or solidifying, whatever you want to write, all of those would be the correct answer for that
Does
one.
hardening come under it?
I suppose so, but we don't really use that in science for this word. Okay, so just use one of the actual keywords, because science is a bit funny. If you don't use the proper words, sometimes people will say you're wrong. So yeah, just stick to the correct words. Okay, has everybody got that down?
Yeah. Yeah, I'm still writing.
Okay. Just let me know when you're done. You got your hand up?
Done.
No, okay. All right, brilliant. Let's move on. So this is just the same thing that we've just learned, but in a kind of diagram form. So we've got a solid to turn into a liquid, it's melting. A liquid to turn into a gas, we've got evaporates or it boils. When a gas condenses, it turns back into a liquid, and when a liquid solidifies or freezes, it becomes a solid. Just quickly make a sketch of this in your books. It doesn't have to have curved arrows. You can literally put straight arrows if you want. I really don't mind. You can just put the arrow between the words and then write the word on the arrow. I don't mind, but just have this down. And then we've got two big massive arrows. So it doesn't have to be massive, but the reason it's massive is it's going straight from solid all the way to gas, and then straight from gas all the way to solid. If you know the name of those words, write that down.
Do we have to know the names? Because I don't know the names.
No. I don't expect you to know it unless you've studied that before. So for now, just draw this out. Make sure you leave enough space to put the words on. So don't squish it all in. Make it so that when you look at it, you'd actually want to read it.
And Miss, what does condenses mean?
Look at the picture and you tell me. Where's the arrow coming from and where's it going to?
So
Just read it like.
Is it
Yeah.
like a gas turns into a liquid?
Excellent. I've just noticed there's a spelling mistake on here. So this L and I have to be the other way around. So just turn them around, okay?
Yeah.
So it's SOLI, not IL. I've put an arrow there anyway to show you.
Done.
Okay. Have you drawn the big arrows going from solid to gas and gas to solid as well?
Yeah.
Okay, excellent.
I'm done, Miss.
Okay. I'm going to give it 10 more seconds and then we'll move on. Okay, right, so Does anybody have any questions as to what any of these words mean? Melts, evaporates, condense, or solidifies?
No.
No?
No.
Okay, right. So when a solid turns into a gas, it doesn't happen very often, but when it does, it's something that has a very, very low boiling point. Means that it boils or it evaporates at a very, very, very low temperature. So even as soon as it's a solid and you take it out into the room temperature, straight away, it will just turn into a gas. It doesn't have time to turn into a liquid because it just boils or evaporates really quickly. The word for that, oopsie daisy, where have I put that word? Anyway, the word for that is sublimation. I'm just going to add that on for you because apparently I haven't. Okay, so sublimation, not sublimation.
Is it if I write that down?
Yes, please. So on your big arrow from solid to gas, just add in the word sublimation. And then on the arrow from gas to solid, so if a gas turns into a solid without turning into a liquid on the way, we call it deposition. Just also going to just change this word because it's irritating me. Okay, back to the slideshow. All right. Has everybody got those words down now?
Yeah.
Okay, so if anybody says something has sublimed, it means it was a solid and the energy increased so much that it straight away turned into a gas. So it went from having particles that are so closely packed together to particles that are bumping off each other and spreading out as fast as they can. There was no middle ground there. It just went from one end to the other, and the same onto this side. Now this is starter, but this is for the next section, so it's the next lesson basically. I've got some pictures there of some flasks. These glass containers are called conical flasks, and they're used in science labs. So what we've got here is somebody has put some ink or some dye into some water, and it's showing you what's happening over time. So the question I'd like you to answer is, after 5 minutes, what do you think will happen to the ink in the final beaker? So in this last beaker, what do you think will happen? And then if you can explain why that happens, that would be great. So once you've dropped some ink into a beaker or into a flask, whatever it might be, after a while, after 5 minutes, what do you think would happen? So just write that down.
Does it have water in it?
Yeah, so we've got water up to this point, and then we've dropped some ink, some blue ink or blue dye into there. What's going to happen after 5 minutes? As in, what would you expect to see when you looked at that conical flask?
So the that's water, and then the blue thing is not anything. Is it just ink?
Yeah, it's just ink. So what's going to happen after 5 minutes? Imagine you did that and then you looked at it and then you went away for 5 minutes and you came back. What would you expect it to look like? Assalamu alaikum, Yusuf. Welcome. Okay. For now, what we're doing is just answering the question that's on the screen right now, okay?
Okay.
Miss, I'm done.
Okay. Can you do the extension as well while you're at it?
Yeah, I've done it.
You've done the extension as well?
Yeah.
Oh, okay. All right, just where's my screen? While you're waiting then, if you could just think of an example where you've seen this kind of thing happen in real life.
Done.
Okay.
I'm done. Done.
Dokes. All right, so Fatima A, tell me, what do you think will happen to the ink after 5 minutes?
After 5 minutes, the ink will it will mix into the water, so the whole all of the water will go like completely blue, and you can't see any clearness of the water left.
Okay, so you think all of the water will become blue, Mishkat?
I agree with her, and I think that is gonna stay as a liquid, or it might evaporate. I don't think it will, but it might.
Okay, so it will stay as a liquid, that's correct. And does anybody have anything else to add to those answers?
Yeah, it
Okay.
won't be fully blue, but it'll be blue, but it'll still be see-through. It's not like you can't see through it.
Okay, so you think that it will be translucent, so some light will pass through it. That's
Yeah.
correct too. Muhammad, is your hand still up? No. Okay, right. So all of you are correct in that. So the blue will spread out, the water will become completely blue. However, it won't become opaque, so you will still be able to pass light through it. Did anybody have any explanation as to why that would happen?
Because the ink or like the color, it'll be trapped and like something to do with water particles, I think.
Something to do with water particles, that's right. Does anybody know what that something is?
No.
No.
I
Okay,
learned
that's
it
fine.
maybe about 1 year ago, so I can't remember that much.
That's fine. All right, so what we'll do is that the whole point is to teach you that anyway, so that's great. Okay, so after 5 minutes, the ink will have spread out equally around the solution. So the entire liquid portion will be blue. So the question was, what is this called? And the reason I didn't give you a title is because that is our title. So here we are.
Blend.
Yeah, but we don't use that word in science. We're going to call it diffusion, okay? So if you could just get that down. So put this down as another lesson. So you've got the title now, a new title, diffusion. So when things, well, I'll tell you what the explanation is, but what you see in that water flask with the ink is called diffusion. Your learning objective is just understand why some things spread out. So some keywords that we've got are diffusion, particles, concentration, equilibrium. For the careers, I've just left the same ones as yesterday, just because it is still concerning particles.
Okay. So do you want us to write like all of these, define, describe?
No. You just write the title, which is diffusion, and the
Yeah.
learning objective, which is
Okay.
understand why something spread out. And then obviously you should have your date down already. You're more than welcome to write it again. I don't mind.
Okay, so okay, right, that's fine.
Date, title, and LO. Let's see. And remember that we're underlining our dates and titles. Okay, so for our journey of the lesson today, we're going to define diffusion. So you've got some kind of idea of what it is now that you've seen that picture, but we're going to give a proper definition. So we're going to give you, learn the meaning in the way that we kind of need to learn it with the keywords. Then we're going to move on to describe things that will affect diffusion. So things that will make diffusion happen faster or that will make it go more slowly. And if you have time, we'll do that last section too, but that's just, it's a very small part anyway. Okay, right, Bismillah. So diffusion is something that happens naturally, okay? So it doesn't need any energy. You don't need to feed anything in order to make it happen. Just by whatever it is that goes on, it's going to just happen automatically without the need for energy. So it's what we call a passive process. Okay, passive means something that will happen without anybody else having to do anything about it. Okay, so for example, if somebody hit you, you didn't have to do anything. Well, actually, you might have, but just pretend you didn't. If they hit you for no reason, you were passive in that story, and the person who did the hitting is the active person. Okay, so you didn't have to do anything. In the same way, with diffusion, you don't need to do anything, or as in the particles will automatically go and diffuse. They don't need any energy or any input from yourself.
What's the word again?
As in when you don't have to do anything?
Yeah.
Passive. So that's P-A-S-S-I-V-E. P-A-S-S-I-V-E. Oh dear me, what a P is that? Okay. Right, so moving on from there. We know that in a solid, the particles vibrate. They aren't free to move because they're closely packed together. In a liquid, they do vibrate, but they also flow over each other. So there is a bit of movement. And then in a gas, they move randomly and they move freely. We learned that yesterday. So because of this, diffusion can happen in some of these states. It won't happen in all of them, but we'll come to that in a little while. Okay, because we just said that diffusion is when things are spreading out, and we're going to learn about what we need in order to make that happen. So I'd like you to write this definition down in just a moment. Don't write it yet. Let's just go through it and let me explain what it means. Okay, so diffusion is the movement of particles. So whatever particles they are, so in this case, it was the ink particles, they move from an area of high concentration. What does high concentration mean? Yes, Fatima F.
Is it like when it's quite a lot in that thing? Like
Excellent, well done. So it means when there's a lot of them, so a lot of those particles in an area, they're going to move to an area where there's not a lot of them. So it doesn't mean that there's zero. Sometimes it can do, but it can just mean that there's a lower concentration. So in one area, there's a lot. In one area, there's not so many. And this will carry on. So the movement of particles will carry on until they're going to be equally spread out. So as you mentioned earlier, the water would become completely blue. So it would be blue all around, so not just in the middle or not just where you dropped the ink. It would become blue all over. So that would be the movement of particles from an area of high concentration, basically where you dropped the ink, to an area of lower concentration, so all the areas where you didn't drop the ink, until they are equally spread out. So basically until the whole of this becomes blue. And when something's equally spread out, in this lesson anyway, in this context, we call that equilibrium. So what I'd like you to do now is write this definition down, leave space around it so you can put a box around it or highlight it or something so that you know that this is a very important definition. This definition you will need even up to year 11 and further if you're going to study science after year 11 as well. Okay, so just write this down and make sure you learn it. So it's the movement of particles from an area of high concentration to an area of lower concentration until they reach equilibrium or until they are equally spread out. So just write that down for me, please. Mishkat, have you got a question?
No.
No, okay.
Done.
Okay. Are we all done? No? Okay. I'll give you a few more seconds. You're done. All right.
What do we do after this?
We're going to find out what things affect the rate of diffusion. Okay. So what we're going to do before we move on to the factors that affect diffusion, I've just got a little video for you to watch. When you're watching that video, I want you to think about this definition that you've just written down. And you're going to explain to me how what you see in the video is going to be very similar to what you've just learnt, and then how it's also different. Aisha, you got a question?
Can I go get the charger because my laptop's about to die?
Yeah, sure. Okay, so where's my screen gone? Okay, so every year in November, there's a day that is known as Black Friday. Have you heard of that before?
Yeah.
Yeah.
Okay, so this is when people usually sell things at discounted prices or at lower prices, and then they put deals on and everybody goes a little bit crazy. So as you watch the video, just think about the definition. So this definition that you just learned, the movement of particles from an area of high concentration, basically where there's a lot of it, to an area of lower concentration until they are equally spread out. So I want you to watch the video, think about how the people are acting in the way that we've mentioned on this definition, and also how they are not acting in the way that's in this definition. So let's see, hear it.
Okay.
Well, once it starts making sound anyway. Can you hear that?
Yeah.
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 Okay. To be honest, the sound isn't important to this video anyway, but just watch.
It's Bieber! It's Bieber! Stealing my idea. Stealing my idea.